Today I've got an exam question from the chemistry of the atmosphere topic. It's got a couple of questions on one side, a couple of questions on the other side, so it should take around 5 minutes. I've missed out the first part of the question because it relates to crude oil, so this is just going to be about pollution. So transport is a source of atmospheric pollutants. Suggest how sulfur dioxide can be produced by transport. How is it produced by transport? So transport involves obviously cars, vehicles. The fuels that those cars and vehicles put into their engines contain sulfur. It's that sulfur, well not all fuels, but some fuels contain sulfur. And that sulfur can react with the oxygen in the air to produce sulfur dioxide. That's how sulfur dioxide is made. So some fuels contain sulfur. This reacts with oxygen to produce sulfur dioxide, so 2 marks there. Give 2 problems caused by sulfur dioxide as an atmospheric pollutant. So we have sulfur dioxide in the air dissolves in the rainwater. That makes the rainwater acidic. That falls then as acid rain, and we can just write acid rain. And acid rain causes a few environmental problems. But just writing acid rain on its own is enough here. The other problem with sulfur dioxide is that it can cause respiratory or breathing difficulties in people. For example, asthma. So we could just write respiratory problems here. So this is not a describe or an explain, this is just a give, just stating them. Describe how carbon monoxide can be produced by transport. So carbon monoxide is a product of incomplete combustion of a fuel. So normally when a fuel is burnt, carbon dioxide is produced as a waste product. If there isn't enough oxygen, it can't make carbon dioxide. Carbon monoxide is produced instead. It's got one less oxygen molecule. So it's when fuels are burnt, but it's the oxygen that's in limited supply. Instead of complete combustion occurring, incomplete combustion occurs instead. Fuels are burnt, but with a limited oxygen supply. This is incomplete combustion. All right, last question. Catalytic converters are fitted to car exhausts to reduce the amount of pollution from cars. Carbon monoxide and nitrogen dioxide react in a catalytic converter. So these two are our reactants, and carbon dioxide are produced. These are our products. We have to write a balanced equation for the reaction. So the first thing we can do is get the symbols in. So this has to be a symbol equation, not a word equation. So carbon monoxide is CO. Nitrogen dioxide is given here, it's NO2. Nitrogen is N2, it's diatomic, so it goes around in pairs. Carbon dioxide is CO2. Now you may have been taught a certain way to do this. The way I do it, if it's not immediately obvious, is to go left and right side. And then we are going to just do a kind of a tally of the elements on each side. So we've got carbon, oxygen and nitrogen. On the left side, we've got 1 atom of carbon. On the right side, we've got 2. On the left side, we've got 1, 2, 3 oxygen atoms. On the right side, we've got 2. On the left side, we've got 1 nitrogen atom. On the left side, 1, and on the right side, 2. Now, all of those elements are not balanced at the minute, so we've got quite a bit of work to do. Sorry, that should be 1, my mistake. We've got a bit of work to do here. So let's start with oxygen. So I'm going to have a look. So I've got 3 on here and 2 on the right. So I have to adjust the ones on the right. The only way I can do that is to change this from 1 molecule of carbon dioxide to 2, which I'm just going to use a pencil for. Once I've made that change, it's like a kind of a draft change, I'm going to adjust my table. So now I've got 2 carbons on the right. I've also now got 4 oxygens. So that's actually given me more problems than I started with, but that's okay. It has to get worse before it gets better. So let's look at, we looked at oxygen there. Let's try and change the oxygen on this side, but we can change the carbon as well. So we need more carbons and more oxygens on the left side. So let's adjust this to be a 2. So now we can update our carbons to 2 on the left side, and our oxygens are now going to move to 4. So we've got 1, 2, 3, 4. So our carbons are now balanced, our oxygens are now balanced, but our nitrogen is not. So we need to adjust the number of nitrogens on the left side. So the only option available to us is to change that to a 2. So that changes that to 2 nitrogens, which is now balanced. But the oxygens, now we have to change again. So we've got 1, 2, but now we've got 4 here. So that moves to 6. So obviously this is not balanced. So we need to change more oxygens on the right. So the only thing we can do is bump that up again to 3. So now we've got 3 carbons, and we've also got 6 oxygens here. So our oxygens are balanced, but now our carbons aren't. So we're going to have to change this again now. Change that to a 3. So now we have 3 carbons. We have 3 plus 4, 7 oxygens. Still not balanced. Let's change. We've got to have more carbons here. So we're going to go 4 carbon dioxide. So that takes the carbons over here to, the carbons over here to 4, but it changes the oxygens to 8. Change this to a 4. We now have 4 carbons, and we've got 4 plus 4, which is 8 oxygens. So we're now balanced. Carbon's balanced, oxygen's balanced, nitrogen's balanced. So this is our final balanced symbol equation. This did take a few minutes longer than you would hope for 2 marks, but it's always something you could leave to the end. Make sure you've got the time, but that is the most kind of logical way to do it. You can just randomly put numbers and add up, but I just like this because it's a bit more logical, and you can see how it's progressing. Keep track of it as well. All right, guys, I hope that helps.